Hi, in this video, we're going to talk about shallow copy versus deep copy. So when we talk about the comparison operators for user-defined types, one of the last things that we did was that once the then the equal and then the LT method were defined for the vector class, we sort a list of vectors. And so that works. We sort the list of vectors by the magnitude. And so I don't know if you wonder at the time, and that is, well, obviously these two lists of vectors, they are different, but exactly how different are they? So for example, if I change, let's say the one of the vectors in the original list, does the what would happen to the sorted list of vectors? So let's do exactly that. So let's change the second vector, x and y, to different values, and let's see what happens. So when we run this, we can see that indeed the second vector of the original unsorted list, well, the x and y gets updated. Now, very interestingly, the last vector in the sorted list, the x and y also are updated exactly the same way as the original list of vectors, or that second vector in the original list of vectors. So why is that? Is the sorted vector, is it a reference to the vectors, or is it a copy of the vectors? And it seems to point both ways, that if you're looking at sorted vector and the original list of vector, they are in different orders. So you can say that, well, they are not referencing the same list, right? However, as we just saw, that if we change one of the vectors in the original list of vectors, the vectors in the sorted list also seem to change. So they're not exactly copies of each other either. So what's going on here? So to understand that, let's start from the beginning with what we knew uh, previously about assignment, right? So if I have a list of vectors and then I assign the list to a different name, then these two names, they would refer to the same list, right? And so when we print it out, like I did here, and we should see both of them showing exactly the same list of vectors. Now, the next thing we would try is, if we make any modifications to the list itself, then we should expect that both vectors and vectors1, they should see the same changes, because they point to the same list. So the change we're going to make is, we're actually going to try to swap two vectors in the list with each other. Now, just a quick digression about how to swap things in Python. So one way that doesn't work in any language, that is, if we just simply say, assign vectors at index 2 to 1 and the vectors at index 1 to 2, well, that doesn't swap. It would just assign both of them to point to the original vectors too, and you should understand why. Now, uh, then there is another way to do, well, there's the correct way in other languages to do it is to assign, let's say, the vector at index 2 to a temporary value, and then we assign the vectors at index 1 to 2, and then finally we take that temporary value, which was the original vector at index 2, and assign it to 1. So that would successfully and correctly swap the vectors at these two positions in the list. So that works, but that's actually, that's not quite the let's say the elegant way to do it in Python. And the Pythonic way to do it is to actually do a sort of a tuple assignment here, that it actually simultaneously assign the vectors at index 2 to 1 at, and the vectors at index 1 to 2. So, so this actually would correctly swap the two. So that's a quick digression. of how to swap two variables in Python. But anyway, let's get back to what we were talking about now. So let's step through the code here. What happens when the swap actually happens? Well, what happens is the vector, the element at vectors at index 1, that now points to what the element at index 2 used to point to, which is this one, right? So this is the original picture. 2 points here, and now 1 would point here, and then the element at index 2 would point to what the element at index 1 used to point to. So if we print that out, we obviously expect to see the same thing, but with just these two things swapped now, because again, vectors 1 and vectors, they both are referencing the exact same list. So that's in the case of reference, that every changes made in vectors would be reflected in vectors 1. Now, what if we don't want that? So what if we want to be able to swap things and otherwise rearrange things in vectors without affecting vectors 1? Well, we can do what's called a shallow copy, and that's achieved by copy.copy. And what shallow copy does is it'll make copy, but only for the top level thing. So it will only do a copy one level, but everything below that, they still reference the same thing. So let's see how that works. Well, let me actually show you the result of the code being run first. So this does exactly the same thing as before, other than the copy.copy. It does a swap and it print both of them out. And now that you can see the original vectors and the vectors 1, which is the shallow copy, it's different. And now let's actually step through the code and see what happens. So what copy.copy do after we execute this line is that it creates a 1 level deep copy. So it creates another list. Okay, and the elements in this list, what they point to is they point to the exact same vectors as their corresponding elements in the original vectors point to. So vectors in vectors index 1, it points to the same vector as the vectors 1 index 1 point to, and same thing for 2, etc. Okay, so that's what the shallow copy is. Copies of 1 level, but anything beyond that is still point to the same instances. Okay, so when we do the swap here, so we change what the elements in vectors point to, but that does not affect what the elements in vectors 1 point to. So that's why when we print out vectors and vectors 1, the order of the vectors in these two lists, they are now different. Now, what if instead of changing what an element in the list points to, what if we change an attribute of that element? So in other words, let's say we look at the vector at the index 1 of the list of vectors, and we change the x and y's. What happens in this case? Well, so vectors 1, that's this vector, and we change the dot x and dot y, so it would actually changes the attributes in this vector instance that this points to. And guess what happens when we print out both vectors and vectors 1? Well, because vectors 1 index 1, that also points to the same vector instance, you would expect that both of these elements in both of these vectors, they will see the same change. And that is indeed the case here, that these two, even though we only change through vectors, the element at index 1, both of these lists, when printed out, they see the same changes. So, and to prove that I'm not lying, I'll run the code, and that's exactly what we just saw in the slides. Now, what if this is not desirable? That if we change the vectors in the original list, we don't want those changes to be reflected in the copy of the original list. Well, we can do what's called a deep copy. So, and to do a deep copy, we use copy.deepcopy. And so what a deep copy does is it makes a copy, but unlike shallow copy, which makes a copy but only to one level deep, this recursively makes copy of everything. So what happens when we do call the copy.deepcopy is because it was copying the list of vectors, so it will first make a copy of the list. So it will make a copy of the list, and then it will copy element by element. So for the vectors at index 0, it will make a copy of the instance of vector that this points to, and this is the copy, and it will have the copy of the list first element to point to the copy of this vector, and then it will make a copy of the second element. It will have the second element of the copy of the list to point to the second element to point to the copy of the second element, and so it does for the last element as well. So this is the picture that we end up with, and note that again the copy now and everything that it points to that is reachable from the copy has nothing to do with anything in the original list. So as we step through this, and if we, let's say, change one of the vectors in the original list, well, that only changes the vector, this vector, but it doesn't change the copy of the vector. So when we print it out, the two are indeed different. And again, to show that I'm not lying, here is the code, and I'll run it. I'll show you that even though we changed the this vector in the original list of vectors, we don't change the copy, or deep copy here. So given what we just learned, I would like you to go back to our original question about the built-in function sorted and the list of sorted vectors that they return. Is it a reference? Is it a copy of the original vector? So please pause the video and think about this for a moment. All right, so hopefully you have thought about it and arrived at the conclusion that sorted actually return a shallow copy of the original list of vectors. And the reason for that is, well, we see that the sorted vectors, the orders are different from the original list of vectors, so it's definitely a copy, right? It's not a reference. Now, between the choice of shallow and deep copy, if we change one of the elements in the original list of vectors, that change actually reflected in our sorted list of vectors as well. So these two lists, they are still referencing the same instances of vectors. And they just happen to have a different view of how they are sorted. So as a summary, we actually study 3 different operations. The first one is just the plain old assignment. And when you do the assignment, the two things that they reference the same instance, the same object, so nothing new there. And then the second thing is a shallow copy when we do a copy.copy. And so the vectors 1 is a shallow copy of vectors that shallow copies are only one level deep. So that, the vectors 1, the copy, it has all the copies of all the attributes of vectors. Now the attributes of vectors in this case, we mean the elements. right? Because vectors is a list. But each of these attributes or elements, they are references to the same instances in the original object, or in this case, list. Okay, and finally, the deep copy, when we do a copy.deepcopy, and what it does is it all the attributes and everything referenced by them, right? Whether it's 1 level deep, 2 level deep, 10 level deep, they are all copied, and or in other words, everything is really recursively copied. And at the end of this operation, the original and the copy, they don't reference any of the same thing. They're completely separate from each other. And in terms of usefulness, actually, references are probably the most useful, and that's why the assignment operator in Python, that's its default behavior. Okay, and shallow copy, as we just saw, it's probably kind of good enough, kind of depending on the use case, obviously. Now, in the case of sorted, that's the behavior that it chooses, and it makes sense that it's sorted a list, but the list, each of the elements, they are still the same elements of the original list. So, and now deep copy is actually probably sounds a lot less useful than it actually is. And one of the problems with deep copy is that it takes a lot of time and also a lot of kind of memory to make a deep copy of everything. So it could be slow and takes up a lot of room, and therefore it's actually really not that useful. Now, another thing I want to mention is so everything in Python, everything's customizable. So if you're not happy with what copy.copy or copy.deepcopy provides, you can actually override its behavior by defining a dunder copy method for a user-defined type. And I've never had to do that myself, but because the behavior provided by the copy module is really good enough for most of the things that I can think of. But in case you need to do something different, it's possible. Okay, and just as a final kind of mention for other languages, Java, it actually has no default implementation for copy or cloning, and you have to do entirely your own thing. C++ does have a default implementation for copy, and it's a shallow copy, and it's actually quite a lot of work if you want to do deep copy in C++. You basically have to kind of, for everything that you're copying, you have to write your own code for it. Whereas in Python, you can call copy.deepcopy, and it does the right thing most of the time. Now, so one more exercise before we end this topic, and that is, we know that we can use the is test to check if two names or reference the same object or same instance, right? So given this code fragment, which we have a list of vectors, and we do a reference, do a shallow copy, then do a deep copy, and try to go through it in your head first, right? What each of these is tests evaluate true, whether true or false. And once you're done going through this by hand yourself, then you can type the code in your Python interpreter and verify that your understanding is correct.